Okay, question 1. I've got the coordinates of 2 points, A and B, and I need to find the coordinates of the midpoint. So I'm going to find halfway between those two x coordinates, which is 9, and halfway between those two y coordinates, which is minus 1.5. So my midpoint will have coordinates 9 and minus 1.5. Okay, a line has equation y equals 2 minus 3x. Write down the gradient. Well, it's in the form y equals, so I know that the gradient is simply the coefficient on the x. So that's simply minus 3. Okay, a line has this equation. Does the point with those coordinates lie on the line? Okay, let's have a look. Well, I notice this point has an x coordinate of 100. So let's see what our equation says that y should be if x is 100. Y would be, substitute 100 in there instead of x, y would be minus 298. Oh, not minus 302. So does this point lie on the line? No, it doesn't. Okay. Find the lowest common multiple. The lowest common multiple of these two numbers. Right, well, 28, that's 4 times 7, which is 2 times 2 times 7. So 28 is 2 times 2 times 7. Right, over here, let's do 105. 105 is 21 times 5, which is 3 times 7. So 105 is 3 times 5 times 7. Right, so the lowest common multiple. It's going to need 2 times 2, so that 28 is going to divide in okay. It's going to need a 3 and a 5 to take care of those. It's going to need a 7. So the lowest common multiple is 2 times 2 times 3 times 5 times 7, which is 420. Okay, number 3. The diagram shows a shape. Yes, it does. The shape has an area of 129 square centimetres. Work out the value of x. Well, I can cut my shape here, and this gives me a shape A and a shape B. Well, shape A has an area of 9 times 12. Well, that's 108, isn't it? And that means that shape B, well, its area must be 129 minus 108, because the whole thing has an area of 129. So that means that shape B must have an area of 21. Now let's have a look at shape B. It looks like this. This is x. Now what's this length here? Looking at the diagram, I've got 6 to here, and it must be another 3, mustn't it, to give me 9. So that obviously measures 3. So that means that 3x, 3 times x must be 21. So x must be 7. Okay, question 4. The table shows information about the weights in kilograms of 40 babies. Okay, all right, write down the modal class. The most common class is between 3 and 4, because that's got more babies in it than any other. Work out an estimate for the mean. Right, so I'm going to need the midpoints here. So I'm going to have 2.5, 12 2.5s gives me 30. 2.5 times 12 equals 30. Then I've got 3.5, I've got 4.5, 5.5, 6.5. Right, so my 16 babies who measure 3.5 each, that gives me a total of 56. My 9 babies, who I'm going to assume are 4.5 kilograms each, gives me 40.5. My 2 babies, who measure 5.5 each, gives me 11. And my 1 baby, which measures 6.5, gives me a total weight of 6.5. So what is the total of those weights? Let's have a look. Total weight is going to be these numbers. Added together, 30 plus 56 plus 40.5 plus 11 plus 6.5 gives me a total weight of 144. So the mean is the total weight divided by the number of babies. 144 divided by 40. 144 divided by 40 gives me a mean of 3.6. Have a quick check to see that that seems to be an appropriate average weight. I think it probably does. One of the 40 babies is going to be chosen at random. Find the probability that the baby has a weight of more than 5 kilograms. Let's have a look. How many babies have a weight of more than 5 kilograms? Well, these two do, and so does that one. So there are 3 babies out of the 40 who have a weight of more than 5 kilograms. So my answer is 3/40. Right, question 5. 120 children go on an activity holiday. The ratio of girls to the number of boys is 3 to 5. I bet I can use that to find how many girls and how many boys there are. Let's have a look. So you've got girls, boys, 3 to 5. That gives you a total of 8. And we've got a total of 120 children, haven't we? So 120 divided by 8, that's times by 15. So that means that I must have 3 15s, 45 girls, and 5 15s, 75 boys. Okay. On a Sunday, all the children either go sailing or climbing. 16/25 of the boys go climbing. Well, I know how many boys there are. There are 75 boys, aren't there? So 16/25 of the 75 boys go climbing. So how many boys is that who go climbing? Well, 16 over 25 times by 75 tells me that 48 boys climb. There we go. Okay, so 48 boys are climbing. Then I can work out how many boys are not climbing. How many boys are sailing? So that must be 75 minus 48. 27 boys are sailing. Okay. Now I still don't know what the 45 girls are doing. Twice as many girls go sailing as go climbing. Well, let's have a look. There are 45 girls, aren't there? And if twice as many go sailing as go climbing, then I must have sailing, climbing. I must have a third of them go climbing, 15 go climbing, and 30 go sailing. Okay. Right, work out how many children go sailing on Sunday. That's the question, isn't it? So I better answer that one. So sailing is going to be 30 girls plus 27 boys equals 57. 57. Okay, question 6. Right, I've got to write this number, which is given in standard form, as an ordinary number. So I'm going to start 7.8 times 10 to the minus 4. So I need to divide it by 10 4 times. So I'm going to divide it by 10 once. And then I'm going to divide it by 10 3 more times. So I'm going to have 3 zeros and then the digits 7 and 8. Work out this. Give your answer in standard form. Right, well, if I put all that into my calculator, then my calculator tells me that this equals 225 00000, which happens to be 22,500,000. But of course, I need to now put that answer in standard form. So that's going to be 2.25 times 10 to the what? 1, 2, 3, 4, 5, 6, 7. There we go. 2.25 times 10 to the 7. Okay, question 7. Expand and simplify. Well, I'm going to have m squared, get minus 8m and plus 5m, so minus 3m, and minus 8 times plus 5 is minus 40. M squared minus 3m minus 40. Factorise fully. Well, I can take out a 5 and I can take out a y. Going to give me a 1 and 4y. 5y, lots of 1 plus 4y. Okay. C, simplify, and look at this. Something to the power of 0 is just 1, isn't it? Anything to the power of 0 is 1, so the answer to that is simply 1. Solve this equation, show clear algebraic working. Well, the first thing I'm going to do is multiply out the left-hand side. That's going to give me 6x minus 15 equals 9 minus x divided by 2. Get rid of that divided by 2. So I'm going to multiply both sides by 2. That's going to give me 12x minus 30 equals 9 minus x. Now I've got an equation with x's on both sides. See which side has the least x's and get rid of them. The right-hand side has the least, so I'm going to add x to both sides. Gives me 13x minus 30 equals 9. Get the x's on their own, so add 30 to both sides. Gives me 13x equals 39. Divide both sides by 13. X is 3. There we go. X equals 3. And that is question 6 and 7 done. Okay, question 8. On the grid, enlarge the shaded shape with a scale factor of 1/2 and centre 1, 2. So the centre of enlargement is here at 1, 2, and I have to enlarge this the scale factor of 1/2. Let's find where this point would go. First of all, now to get to that point, it is, the whole thing is, what's that, about 1 to 7, so it's 6 along and 8 up, isn't it? Well, halfway is going to be here, 3 along and 4 up. So this point is going to come to there. Now I can probably work out the other points from there, because if it's a scale factor of 1/2, it's no longer going to be 8, the width of that shape. It's only going to be 4. So it's going to come from here and be 4. Right. It's not going to be 6 high. It's only going to be 3 high. So it's going to go to there. It's not going to be 4 wide at the bottom there. It's only going to be 2 wide. Right, so that's there. And now I simply need to join it to where it starts. So there is my new shape. Okay. Here's a right angle triangle. Right, a right angle triangle. Could be Pythagoras, could be trigonometry. Let's have a look. Calculate the length of PQ. Right, well, let's call that X, just to make sure we know which side we're talking about. Give your answer correct to 3 significant figures. I'm not going to want to forget that. Right, well, I don't know 3 sides, so I'm going to use trigonometry here. I'm going to use cos. Here we go. And in this case here, I'm finding the hypotenuse. So the hypotenuse x is going to be the adjacent divided by cos 63. So the hypotenuse x is going to be 24.3 divided by cos 63. So 24.3 divided by cos 63 equals, and that gives me 53.525. Now I've got to give it to 3 significant figures, so that's going to be 53.5. 53.5. Let's just see, does that look realistic? Well, it does look realistic, doesn't it? If the height is 24 and this is a large angle, larger than 45. So I think that looks about right to me. That's number 9 done, and that is 8 and 9 finished. Okay, the shaded region in the diagram is bounded by 3 lines. Right. The equations of one of these lines is given. Yes, it is. Write down the 3 inequalities that define the shaded region. Well, looking at the first one here, let's start off by looking at the line that we're given the equation of. Okay, so that line is the line y equals a third x minus 2. So we're interested in the points above it. So the inequality is going to be y is greater than a third x minus 2. But careful, because it's a solid line, so it's to be y is greater than or equal to a third x minus 2. So that's all the points which lie above this line here. Good. Now, let's concentrate next on this line. Right, now that is the vertical line that crosses the x-axis at -1. So it is the line x equals -1. And the points I'm interested in have an x-coordinate of greater than or equal to -1. So my inequality is going to be x is greater than or equal to -1. All right, now we only got one more line to do, and that is this line here. So the equation of that line. Well, I could use y equals mx plus c. Now, what's the gradient of that line? I go along 1, I go down 1, along 1, down 1. So the gradient is -1. So it's y equals minus x, and the y coordinate is 4. So the equation of that line is y equals minus x plus 4, and I want the points below that line. So my inequality is going to be y is less than or equal to, because it's a solid line, minus x plus 4. So those are my 3 inequalities. Incidentally, you might have looked at that last line here and said actually its equation is x plus y equals 4, which would have been correct, and in which case your inequality would have been x plus y must be greater than or equal, less than or equal to 4, because the points are below the line. Okay, let's have a look at number 11. Max invests $6,000 in a savings account for 3 years. The account pays compound interest at that rate for the first 2 years. The compound interest rate changes for the 3rd year. At the end of the 3 years, there's a total of that much. Work out the compound interest rate for the 3rd year. Give your answer to 1 decimal place. Right, so he starts off with £6,000. The first year, he gets 1.5%. So the first year, he's going to multiply by that. And then the same for the 2nd year. So after 2 years, we're going to have $6,000 multiplied by 1.015 squared. And then they're going to multiply it by something else for the 3rd year. Let's call that 3rd year multiplier x. And we know that at the end of the 3 years, he has that much money left. So on the left-hand side, I've got 6,000 times by 1.015 squared, which is 6181.35x equals $6,311.16. So I'm going to divide both sides by 6,181.35. So I'm going to do 6,311.16 divided by 6,181.35. And that gives me the answer 1.021. So the multiplier for the 3rd year was 1.021. So the percentage increase must have been 2.1%. Okay, question 12. Right, so in question 12, it says a total of 80 men and women, that'll be useful, took part in a race. The cumulative frequency graph gives information about the times in minutes they took. So here's the cumulative frequency on the y-axis. So here we go up to 80 participants. And here's the time they took on the x-axis. Good. Right, let's have a look at the question. Use the graph to find an estimate for the interquartile range. So I'm going to need to find the upper quartile and the lower quartile, find the difference between them. Right. So, a bit of a deviation perhaps, but the 40th here is going to give me the median. I know we're not interested in the median per se, but I'm going to mark it anyway. So that's the median. So the 40th person is the median. So the lower quartile is going to be the 20th person. The upper quartile is going to be the 60th. So let's have a look at the 20th. So the 20th person is going to be here. So the lower quartile is 20 to 30, 30 to 40, 38, isn't it? All right. And the upper quartile is going to be however long this person has taken. Here we go. There we are. That looks to me like it's 56 minutes. So the upper quartile was 56, and the lower quartile was 38. So the interquartile range is 56 minus 38, which is 18 minutes. 60% of the men took 50 minutes or less for the race. Okay? No women took 50 minutes or less. Okay, so all the people who were 50 minutes or less must have been men. I wonder how many people were 50 minutes or less. Let's have a look. I'm going to delete that bit there. Right, 50 minutes or less. How many people? Let's have a look. Do it in blue. 50 minutes or less. So I'm going up to here, to there, and then across from here. Look at that. 42 people took 50 minutes or less. 42 people. 42 people took 52 minutes. Took 50 minutes, I beg your pardon, or less. Okay, great. And by the way, all those were men. And by the way, that's 60% of the men. So if I just talk about the men for a minute, 60% of the men was 42, which means that 10% must be 42 divided by 6, must be 7 people. So 100% of the men, times that by 10, there must have been 70 men altogether. Oh, work out an estimate for the number of men who took part in the race. There you are, I've done it, haven't I? The answer is 70 men took part in the race, because I know that 42 of the men make up 60% of the men. So the answer is 70 men. Right. Okay. Question 13. The diagram shows a solid cube. Okay. The cube is placed on a table so that the whole of one face of the cube is in contact with the table. Okay, it's just put on a table. The cube exerts a force of 56 newtons, and the pressure on the table is 0.14 newtons per square centimetre. Oh, it gives you a nice formula here. Look, it says that pressure equals force over area. All right, work out the volume of the cube. Well, if you're not sure what to do, you've got a formula there. So let's put in the numbers we know. So the pressure, 0.14, is the force, 56, divided by the area. I wish I knew that area. Well, of course, you can work out the area from this equation here, can't you? The area will be 56 divided by 0.14. So the area of one face of the cube is 400. Okay. So the area of one face of the cube is 400 square centimetres. How's that going to help me find the volume of the cube? I've got to highlight what we're asked to find, the volume of the cube. Well, wait a minute. If the area of that square, the area of the bottom is 400, that means it must be 20 by 20, mustn't it? So W must equal 20. So if W is 20, then the volume must be 20 times 20 times 20. So 20 times 20 times 20 gives me 8,000 cubic centimeters. Okay, question 14 next. Right, the diagram shows a parallelogram. Okay, all right. And there are some lengths given to me and an angle. Work out the area of the parallelogram. So the area of a parallelogram, the area is given by the base times the height, isn't it? And I know the base is 14.7. So if I need to work out the area of the parallelogram, I'm going to need to know its height. Right, let's have a look. I'll tell you what, I'm going to start by labelling the height. Here we go. Label it from there. So that's the height, right? I'll call that h. That's 90 degrees. No, that's 90 degrees. Oh, wait a minute. This is 90 degrees, which means that I know that top angle. That top angle is going to be 16. 106 minus 90. So how can I find that length h? Well, I've got a right angle triangle here, EF down to here, with an angle of h and a hypotenuse of 9.3. So I'm going to use cos here. I'm not actually going to call that h for the height because I might muddle it with h for the hypotenuse because the hypotenuse is 9.3, isn't it? So I'll call that x. So I'm going to use cos. Okay, and I need to find the adjacent, which is x. So x will be cos 16 times the hypotenuse, which is 9.3. So be careful in a calculator that you type 9.3 times cos 16 rather than the other way around. And that gives me a value for x of 8.9397. 397. Okay, so that's the height, isn't it? So therefore I can work out the area of the parallelogram, which will be the base times the height. I've still got that number on my calculator in any case, times 14.7 equals, and look at this, give your answer to 3 significant figures. So looking at my calculator, that gives me 131 square centimeters. Right, work out the length of the diagonal EG of the parallelogram. Okay, give your answer correct to 3 significant figures. Right, I'm just going to get rid of these markings here. And now I'm going to mark on E to G. Right. Oh, I've got a triangle. FEG, and I know 2 sides and the angle. So I can use the cosine rule, I reckon. And look at this, as if by magic. Here's the cosine rule, which of course is given to you on the formula sheet. So if I call angle FA, here we go, then this will help me find the length of little a, won't it? So a squared equals 9.3 squared plus 14.7 squared minus 2 times 9.3 times 14.7 times cos of the angle A, cos 106. So a squared equals, right, I'm going to put that in my calculator, 9.3 squared plus 14.7 squared minus 2 times 9.3 times 14.7 times cos 106 equals, and that gives me an a squared of 377.9447 and so on. So a is obviously the square root of that. Square root answer equals gives me 19.4408 and so on, and I need to give the answer correct to 3 significant figures. So the answer is 19.4. Okay, so I've got a cuboid with that volume. So that, and I've got to show that the volume equals this. So the volume of the cuboid is going to be the length times the width times the height. Okay, so I've just got to expand those three brackets. So the first two brackets multiplied together will give me 2x times 3 is 6x, 2x times minus x is minus 2x squared. 5 times 3 is 15, 5 times minus x is minus 5x. And I've got to multiply that by x plus 1. Before I do, I'll just simplify what's in the first bracket. 6x minus 5x gives me x. I've got minus 2x squared and 15. So now I'm going to multiply that by x plus 1. So I'm going to take this x, multiply it by the x, and multiply it by the 1. X times x is x squared, x times 1 is x. Take this minus 2x squared, multiply it by x, minus 2x cubed, multiply it by 1, minus 2x squared. 15 multiplied by x, 15x, 15 multiplied by 1, 15. Now I hope if I simplify that, it will end up looking like this. Let's see. Well, I see the expression I'm after. It's got the constant term at the front, the 15 at the front. And lo and behold, I've got 15 here, look. Okay, so now it's got x's next. Let's have a look. I've got plus 1x plus 15x gives me plus 16x. Now x squared is next. Well, I've got plus an x squared there and minus 2x squared. So that gives me minus 1x squared. And looking at this, all I've got left is the minus 2x cubes. And that matches the expression that they wanted me to show. So that is good, and that is done. Right, part B. There is a value of x for which the volume of the cuboid is a maximum. Find this value of x. Show you're working clearly. Give your answer correct to 3 significant figures. Right, let's have a look. So we know volume, the expression for the volume that we're working with, was given to us in the first question, and it's v equals 15 plus 16x minus x squared minus 2x cubed. Right, I need to maximize that. So I'm going to start by differentiating the expression with respect to x, which gives me 16 minus 2x minus 6x squared. Good. Right, now I have to find the maximum. So I'm going to solve this equation here. I'm going to start by dividing everything by 2. So that's going to give me 8 minus x minus 3x squared equals 0. I'm going to multiply everything by minus 1 as well and reorder it because then I find it more straightforward. Now, I'm thinking, can I factorize here? But it does say give your answer correct to 3 significant figures. So I'm thinking that actually this is going to be a formula question. So the formula is x equals minus b. Well, let's just write down a is 3, b is 1, c is minus 8. So x equals minus b plus or minus the square root of b squared minus 4 times a times c. Okay, all over 2a, which is 2 3s is 6. So that's going to be minus 1 plus or minus the square root of. Right, let's have a look at this one then. So I've got 4 times a times c. So I've got 1 squared, which is 1, minus 4 times 3 times minus 8. So I've got minus 1 plus or minus the square root of 97 all over 6. Okay, now that's going to give me 2 answers for x, of course. But one of those answers is going to be negative. Minus 1 minus the square root of 97 over 6 will give me a negative answer. And clearly x has to be positive. So the only answer I'm actually going to be interested in is the positive answer to that, which is the square root, which is minus 1 plus the square root of 97 equals, and divide all of that by 6. So that gives me 1.4748 and so on. Now be careful, we've got to give the answer correct to 3 significant figures. So the answer is 1.47 to 3 significant figures. Okay, question 16. I've got a formula that gives me an answer for P here. And it tells me that A It's 58.4, correct to 3 significant figures. C is 20, correct to 2 significant figures. And D is 3.6, correct to 2 significant figures. Work out the upper bound of the value of P. Give your answer correct to 2 decimal places. Let's have a look. Well, first of all, let's just be clear that A could lie between 58.35 and 58.45. C could lie between 19.5 and 20.5. And D could lie between 3.55 and 3.65. Okay, good. Now we want P to be as high as possible. So we're going to take the highest possible value of A. Let's have a look. So P, we're going to take the highest possible value of A. So that's going to be 58.45. Now we have to take away C, so we might as well take away as little as we can get away with. So we'll take away the lowest possible value of C, that being 19.5. And then we need to divide by D. Now, if we want P to be as large as possible, we'll divide by the smallest number possible. So we'll divide by 3.55. So that is going to tell us our upper bound for the value of P. So I'm simply going to type that into my calculator, 3.55, and that gives me an answer of 27.4366 and so on. I need to give the answer to 2 decimal places. So my answer is 27.44. Okay, question 17. Right, I've got to show that this left-hand side is equal to the right-hand side. So what I'm going to do is I'm going to start off by simplifying the left-hand side. So I've got 6 plus 2 root 12 squared. Okay, so I'm simply going to expand these 2 brackets. Gives me 36 plus 12 root 2, and I've got 2 of those, so 24, sorry, root 12, not root 2, plus 4 times 12. So I've got 36 plus 48 plus 24 root 12. So that is 84 plus, I'm going to take out a 4 from the 12. So I'm going to root the 4, so it gets me 48 root 3. Okay, right, now let's have a look at the right-hand side. Now, the right-hand side is 12 lots of 7. 12 sevens are 84, plus 48 root 3, just by multiplying out the bracket. Look at that, they're equal. So I think that is job done. Right, section B. Now, this bracket is to a negative power. So the first thing I'm going to do is to change it. Change the bracket. So now I can write it. It's a positive power. Right. So I'm going to cube root everything. I'm going to leave it to the power of 2 and cube root what's inside the bracket. So the cube root of t to the power 15 is t to the power 5. And the cube root of 27 is 3. Cube root of a to the 12 is a to the 4. So it is simply t5 3a to the 4 times t to the 5 times 3a to the 4, which is simply t to the 10 and 9a to the 8. So there's my final answer. Okay, that is question 17. Okay, so there are 16 sweets in a bowl, right. 4 of them are blackcurrant, 5 are lemon, 7 are orange. Blackcurrant 4, lemon 5, orange 7. 3 people each take at random 1 sweet from the bowl. Work out the probability that the 5 lemon sweets are still in the bowl. So what we need is we need each person not to choose lemon. So we really want not lemon for the first choice, not lemon for the second choice, and not lemon for the third choice. Well, probability of the first person choosing a sweet which is not lemon is 11 out of the 16. Once they've chosen their not lemon sweet, the probability of the second person choosing not lemon is 10, because there are 10 unlemons remaining, and there are only 15 sweets in the bowl. And then the third person, well, they've got 9 non-lemon sweets remaining out of the 14. So the probability of the 3 people, first person choosing not lemon and second person and third person, is given by those 3 fractions multiplied together, which is 990 over 3,360, which cancels down to 33 out of 112. Okay, so I've got to find the length. Sorry, I beg your pardon. I've got a cuboid here, and I've got to work out the size of the angle between AH and the plane EFGH. So I'm going to start by drawing AH. I've got to find the size of that angle. I've got to find the size of the angle between that red line and the plane EFGH. That's the bottom of the shape, isn't it? So essentially what I'm being asked to find is the angle between those 2 red lines, between the line FH and AH. Right, now it's more or less a question of saying, well, what can I find? Well, if you look at the bottom of the shape, you've got a triangle here, FEH, and you can find the length of FH there by using Pythagoras. So FH is going to be the square root of 5 squared plus 9 squared, which is going to be the square root of 25 plus 81, which is going to give you the square root of 106. So FH is the square root of 106. Brilliant. Now, I can also find AH by using Pythagoras. AH is going to be the square root of 5 squared plus 9 squared plus 6 squared. So that is going to be the square root of 142. Good. Okay. I also, by the way, know the length of AF is 6. So this vertical triangle now that's in the middle here, let's just draw that out here. It looks like this. Now this base is the line from F to H, the diagonal line across the base. And that has a length of the square root of 106. The height here is from A down to F, which is 6, and the hypotenuse here is the length AH, which is the square root of 142. And the angle I'm being asked to find is this angle here, which I'll call alpha. So you can use trigonometry now to find alpha. Because you know all 3 sides of the triangle, you could use sine, cos, or tan. I'll use tan. Here we go. So tan of alpha equals the opposite, 6, divided by the adjacent, the square root of 106. So on my calculator, I'm going to work out what 6 divided by the square root of 106 is. Okay, I'm going to press equals on that, and then I'm going to go shift tan to work out my angle. And I have to give the answer to 3 significant figures. So the answer on my calculator is 30.23. So to 3 significant figures, the answer is 30.2. Okay, let's have a look at question 20. Right, the curve C has this equation, where A is greater than 4. Using the axis below, sketch the curve C on your sketch so clearly in terms of A. Right, I'm going to need to check that I show everything that they want to. Right, let's just sketch this graph, shall we? Now, we know that it's a quadratic. Let's get back to it. Here we go. We know it's quadratic. Right. Now, let me just write this down. Y equals 4 lots of x minus 1 squared minus a. Well, when's that going to be at a minimum? It's going to be at a minimum when this lot is 0. And that lot is going to be 0 when x is 1. So, when x is 1, y is equal to minus a. And that is going to be the minimum. There we go. All right. So my curve is going to look something like that. Okay. All right. Now, I'm going to need to find the coordinates of any points of intersection with the coordinate axis. So I'm going to need to find this point here. Now that is the point on the curve when x equals 0. So looking at our equation here, what is that going to equal when x is 0? Let's have a look. If x is 0, then y would be 4 times minus 1 squared, well, that's just 4, minus a. So it'd be, y would be 4 minus a. So this point here has got a y coordinate of 4 minus a. Okay, good. Now, I need to find the points where this curve crosses the x-axis. So that is the coordinates of this point and the coordinates of that point. All right, well, it crosses the x-axis when y is 0, right? Here's my equation. Y equals 4 lots of x minus 1 squared minus a. And I need y to be 0. So the equation which I'm seeking to solve is that one. So let's make x the subject of that equation. Well, it's going to be 4 lots of x minus 1 squared equals a, adding a to both sides. Divide both sides by 4 gives me that. Square rooting both sides. There are going to be 2 answers there, aren't there? Okay. Oh, I can square root the 4, can't I? So actually, that can be simplified to plus or minus the square root of a over 2. And now I can add 1 to both sides to give me x equals 1 plus the square root of a over 2, or 1 minus the square root of a over 2. So those are my 2 options for those x coordinates. So this point here has got an x coordinate of 1 plus the square root of a over 2, and this one has an x coordinate of 1 minus the square root of a over 2. All right, let's just go back to the question. Right. On your sketch, so clearly in terms of A, the coordinates of any points of intersection of C with the coordinate axes. Right, well, I've shown this point, and that point. So I've done that. The coordinates of the turning point, well, I think it's pretty clear, but I suppose I better make it really clear. There we go, and that is the end of question 20. Okay, so we've got 2 functions, f of x and g of x, and they're both defined for us here. And also h of x is defined as being f of the g of x. And we're asked to express the function, find the inverse function, h to the minus 1 of x. Okay, fine. Let's start off by finding h of x, right? H of x is f of g of x. So h of x is f of x plus 3, because that's what g of x is. So when I f something, as I'm about to now, I have to square it. So that's going to be x plus 3 squared, and subtract 2 times it. There we go. Let's simplify this. X plus 3 squared is x squared plus 6x plus 9 minus 2x minus 6. So h of x simplifies to x squared plus 4x plus 3. Okay. Now we need to find the inverse function. Okay. I've lost it. Here it is. We need to find the inverse function. So we're going to find it useful to complete the square here, to write h of x as x plus 2 squared minus 1. Okay, so that's what h of x is. So the inverse function, h to the minus 1 of x, is going to be the inverse of that. So we're going to have the x, going to plus 1, going to square root it, and then minus 2. There you go. So that is the inverse function. Okay, last question of the paper. Triangle HJK is an isosceles with those two sides equal, HJ and HK, and JK equaling root 80. Right, I'm going to start just by drawing a sketch of an isosceles triangle, because I think that'll probably help me. Okay. There we go. Those are the two equal sides. Here's my base. So I've got HJ equals HK. So this can be H, J, and K. These two sides are equal. And JK is the square root of 80. Okay. Great. H has got coordinates. Right, I'll write those on. Minus 4, 1. J has got coordinates. J, 15. And K, where J is greater than 0. I bet that'll be useful later. And K has got coordinates 6, K. Good. All right. M is the midpoint of JK. Okay. So let's put M here. And the gradient of HM, right, that's this line, isn't it? Gradient of HM. Oh, which, by the way, will be perpendicular here, won't it? The gradient of HM is 2. Okay, so I've put that in my diagram, Find the value of J and K. Right, I'm going to need to set up some equations, I think. Now, the first thing that occurs to me is that if the gradient of HM is 2, then the gradient of the base here, well, that's perpendicular to the height, isn't it? So if the gradient of HM is 2, then the gradient of JK is minus a half, the negative reciprocal of 2. Fine. But also, if I look at these coordinates, I can represent the gradient of JK by doing rise over run. So the rise over run. So the difference between the y coordinates over the difference between the x coordinates. I'm going to do the coordinates of j minus those of k. So the rise is going to be 15 minus k, and the run is going to be j minus 6. So that's the gradient, looking at the coordinates, and I know that that equals minus a half. So that tells me that 30 minus 2k equals minus j plus 6, which in turn tells me that j equals 2k minus 24. Okay, well, there's an equation for j in terms of k, so that will be useful soon, I'm sure. Now, I need to set up a second equation. So, another piece of useful information is that I know the length of jk is the square root of 80, and I can also get an expression for the length of jk by using the coordinates and Pythagoras. So the distance from j to k is going to be the square root of the distance between the x coordinate squared plus the distance between the y coordinate squared. Okay, I'm going to do j minus k, make sure I get it the right way around each time. So point j, the coordinates of point j minus coordinates of point k. So it's going to be j minus 6 squared plus 15 minus k squared. That is an expression for the distance jk, and I know that that equals square root of 80. Okay, well I can square both sides for a start, which is going to tell me that j minus 6 squared plus 15 minus k squared equals 80. I don't know why I've written 81 there. Okay, right, so now I've got an equation 1 here and an equation 2 here. And I'm thinking all I need to do is substitute my expression for j from equation 1 into equation 2. So let's have a look. So instead of j, I'm going to substitute 2k minus 24. So this is going to give me minus 30 squared plus 15 minus k squared equals 80. Right, multiply out those brackets. Let's not mess it up. 4k squared minus 120k plus 900 plus 225 minus 30k plus k squared equals 80. I'm just going to get a quadratic equation here, I think. I'm going to have 5k squared minus 120k minus 30k minus 150k. Right, 900 and 225. Okay, and then take away 80. It's going to give me 1045 equals 0. Well, there you go. That's a quadratic equation ready to be solved. I can divide everything by 5. Gives me k squared minus 30k plus 5 into that, 209 equals 0. Now, looking at the question, it doesn't tell me that it wants k or j to a certain degree of accuracy. So I'm assuming that I'll be able to factorize this. And of course, you can factorize it. You know that both of your brackets are going to have a negative in them here. And if you happen to know that 11 times 19 is 209, then you're onto a winner here, because that's how to factorize the left-hand side there. But you could have used the formula. You just got a whole number of answers. So this gives me 2 possible answers for k. K is 11 or 19. Right, let's go back. We've got an equation for j here. We know that j is 2k minus 24. So if k is 11, then j will equal 2 11s, 22 minus 24 minus 2. And if k is 19, then j will be 2 19s, 38, minus 24, 14. So it looks like we've got 2 possible solutions. But you'll remember at the top that we noted that j has to be negative. And only one of these solutions has a negative j. And that is this one, not that one. So the correct answer to the question is that j is minus 2 and k is 11. Mr. Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done, and good luck with your exams.